Hello everyone. This is the part 3 of our series on beginners ROS tutorial with ROS Development Studio. In the last video we saw how to create a node as well as topics, and we also saw how to use ROS service and ROS parameters and examine them, call some services and things like that. So today we will see how to make use of ROS Launch. ROS Launch uh, allows us to start multiple nodes at the same time using a single file. If you recall, in our last video, every time we wanted to start a node, we were running ROS run something, in one terminal. Then in another terminal we were running another ROS run and some commands. So ROS Launch provides a facility. It's a file that contains all these nodes. You can put them together so that you can launch them. So today we'll see how we make use of this facility. So what we'll do, we'll start a shell first. We'll go to our folder catkin_ws cd and source devel setup.bash, just to make sure that the ROS tree is updated. So if I do ROS cd, we have beginners tutorials there. The tab is working, that means beginner tutorial is already installed. And alright, so we have done this. So what we'll do today, we'll create another folder called launch within this beginner tutorial. Okay, then let's go to cd launch, and here we'll create a file, launch file. We'll call it launch file. Let us see if we can use the built-in IDE here. We can write in Vim as we did last time, but let's see if we can make use of the built-in editor here. So probably it will be good. So alright, so here we are in src, we are in beginners tutorial, we are in the launch folder. Okay, so in the right click, then it says new file. So we create a new file here and we call it it says turtle mimic.launch. So we'll write it turtle mimic.launch. Okay, all right. So what we'll do, we'll copy this content and then probably examine it. Control V. So what you see is that it starts with a tag called launch and ends with a tag /launch. It's a XML file again. Then it has two namespace. One is turtle sim1, another is turtle sim2, and each one of them start in node. For example, node package is turtle sim and type is turtle sim node. If you remember, whenever we started node in our last video, we used to write node ROS run turtle sim and turtle sim node. So this is what it's doing. So this is one node it is starting, and another same thing, another turtle sim 2 is another namespace and it is starting another node of same type, and this namespace allows us to use the same variables inside it's a bet each robot has their own variables, so there will not be any conflict between the names here. That's why we use namespace. And finally we start another node called mimic. Okay, and it takes input. Then for this node, input is mapped to turtle sim 1 turtle 1, and output is mapped to turtle sim 2 to turtle 1. We'll see what does it do. So we'll save it anyway. I hope it is already automatically saved. Okay, so it also has its own terminal. Let's see if we so cd catkin source devel setup dot bash. Okay, so source opt ROS kinetic setup dot bash. I don't know why this is giving the error, because it is not able to resolve this name latest here. So let's do it manually and see what happens. Now we have created this launch file. So it says those things. So we create two namespaces, turtle sim 1, turtle sim 2, just to make sure there are no conflicts. Then we start another node called mimic, and input and output to this node is remapped to these values. That means input is taken from turtle 1, turtle sim 1, and output is given to turtle sim 2. We'll see what does it mean. Alright, so now we'll launch it now. So we'll see ROS launch beginners. It is not doing the work we want. So source devel setup dot bash. Now ROS launch beginners tutorials. Yeah, this happened because we in the last command was source opt ROS kinetic setup dot bash. So that was active. So last command remains active. So we again do the same thing. So now it is working fine. So ROS launch beginners tutorials, then turtle mimic dot launch. So tab is working. So if we do this, enter. This something is wrong with this terminal. We will rely on our own terminal. Let's say go here, and we have the file here. That's fine. So we'll say ROS launch beginners tutorial turtle mimic dot launch. You see the process is started. We'll see if we'll see, start the desktop graphical tool, and if we refresh it, does it work? Let's see. So no. So what we'll do is okay, again we'll launch this one. So what you can see is that we started two nodes simultaneously. One is turtle sim 1, another is turtle sim 2. Okay, at the same time we could start it. So that is the advantage of a launch file. Alright, so what we'll do now, so we'll start another terminal, another shell, and we'll publish a command to one. So we'll see ROS topic publish minus R1. Okay, so publish, we say turtle sim 1 slash turtle 1 cmd well minus R1. That means continuously you give this command at a rate of 1 hertz, and before that you have to give geometry message. Fine, so we'll give geometry message twist minus R1. Then this one, this says, this double dash says that following content is not an option, these are values. So okay, so we give this 2.0, 0.0, 0.0, and the angular velocity is 0.0, 0.0, and 1.8. hopefully, okay, minus 1.8, not minus 1.8. so we give this one. If we do this, sorry, see catkin source catkin ws double setup.bash. Oh, there is no comma here, so be careful with this one. Okay, hopefully it is all right now. So what is happening is that turtle sim, both the nodes are now rotating. Now why it is happening, that is what we'll have to understand. Okay, we gave one of them is turtle sim 1, another is turtle sim 2, that we understand, and we gave a command only to the one, but other one is also rotating. So what's going on here? So we'll have to check. All right, to this we will now start another terminal, and we'll say we'll run rqt graph. So takes time. Okay, so what you will see here, I don't know if I can zoom in or not, but hopefully you'll be able to see. It doesn't help much, so okay, fine, doesn't matter. So what we'll see is that so what is happening here, this is the node that publishes this velocity command. Okay, it is giving the this is turtle sim 1 turtle. All right, I wish I could zoom it, but I don't think I can do that. So fine, so this node is publishing to turtle sim 1 turtle 1 cmd well, and that is acts as the input to turtle sim1 turtle 1. So this is called turtle sim1 sim, because you remember we gave the name sim to this one. So anyway, we mentioned this, that you give the command to this one. Now we remember that there was a node called mimic. So mimic takes input from turtle sim1 turtle 1, the pose information it takes, and gives out to turtle sim2 turtle 1. So we mentioned, and this is cmd well, and that is being given to turtle 2 sim. So this is why when you are making the one of the robot move, this is getting transmitted to the other robot by this node called mimic. So mimic, in the mimic we define that input it has to take from turtle sim1 turtle 1, but it takes the pose information. I don't know why, but it gives out the command velocity. That means it reads the input, cannot it can be command velocity as well, but it reads the input from pose and gives out as the command velocity. If I see, let's say all, oh yes, I can zoom in now. Good. So this turtle sim 1 is the namespace, the first namespace. Our robot is given the name sim. If you remember, in the file we give the robot as a name sim. So it takes the input from command well and gives out the pose. All right. So the now this acts as the input to the mimic, and mimic gives us the output to turtle 1 cmd well, that is used by turtle sim 2 sim. It looks okay, means this looks okay, means not much of a problem. So it takes the input from this one, because it gives out the output as this one, and that is being used as the cmd well as output for this node, and that is being taken as the input for turtle sim 2. So it looks okay, means not much of a problem. So this is how this is the reason why both the robots are moving. Okay, so just to summarize, we saw the use of ROS launch. So one of them is you can load multiple nodes at the same time, okay, and you can define all kinds of relationship between the nodes within the launch file itself. As we saw that we created 2 independent nodes, and then we define another node, and which one takes the velocity input from one and passes on to the second. Okay, so this is fine. So what we will do is that we'll go to this one, probably we'll stop this. Yeah, what I stopped, RQT graph we have stopped, and maybe we'll stop this turtle sim. Let's see. Okay, we finished this part. The next option is editor options. This is not very important to you people can go through yourself. So now our next topic is how do we create ROS messages and services. We know what is a message is a data type, or you can say the language through which nodes communicate. Nodes communicate using topics, and topics require message format. It's a template for the message. How do I send a message to another topic? So it's a it's a kind of template for that. And SRV is a more like a service. In order to make a request and receive a response, we need to have a template. So MSG is a template for sending messages, and SRV is more like a template to how do you make making request and receiving response. So this is what it says. It message MSG files are simply text files that describe the fields of ROS message. That means it's a format of sending message. Okay, and so they're saying that they are used to generate source code for messages in different languages. It doesn't matter, once you have ROS message, it can be used by different programs like C++, ROS CPP or ROS Pi, etc. And SRV file similarly describes a service. It's again a template for defining a service, making a request and receiving response. Okay, so what it says, the message files are simple text file. They contain the field type and field name per line. So they will have like this. In 6 you can have, that means it will have, every line will have two parts. One is the field type and field name. So you can have int 8, field type can be one of these, int 8, 16, 32, float, string, time, and other things. And then you have a name. For example, we'll create one. So let's create some messages here. So okay, so we are in the beginners tutorial folder. We'll create a folder called MSG and cd, and what we do, echo int (64). This is the field type, and then you say name num, and pass it on to message num dot msg. Okay, so if you go to this one, there is a num.msg file is created. If you see the content of this one, it has a one line called int64 and num. You can have multiple of such lines. Okay, so let's make it more detailed. Vim num.message. So we'll see string, first name, string, second name, you, int age, and int 32 score. Okay, so we have a more complicated message. So a message file just has these lines. That means one has field type and the field name. So it will have two parts. Each line will have two parts, and one is a field type and field name, and there's a text file. That's all. So it's all right. However, once you make this message, you will have to make some update in the package.html. So what we do, so the vim package.xml. Now we can also do it using the editor itself. So probably it is easier. So we go here. Package.xml. So what we will do, message generation. So we'll see message generation. Yeah, so build depend, this will uncomment. Okay, another is message runtime. So we'll see message runtime. So execute depends. So this also will uncomment. So with the control S, so it saves file. Yeah, control S saves the file. These two files we uncomment. This is important. This we will do in the package.xml. So this is required because it converts into respective source code for different programming languages like C++, Python, or Java, whatever. So this particular thing ensures that this particular format is converted into respective programming languages. Okay, and then we'll also have to make changes in cmake.list. So here we have cmake.list, and we search for find package. So find package will be in the top. So here standard messages are there. After that we just write message generation. This is important. You see, oh, this one. Now catkin in the catkin package. Now let's see catkin package. Control F, catkin package. In catkin package we'll uncomment this line. Control Z. Let's see if there is somewhere else. Okay, so catkin package here, catkin depends message runtime. So we'll just add message runtime. Yeah, so there's no comma or anything, we just add message runtime. Then find the block add message files. Add message files. So what we will do is that we'll uncomment this. And we'll just make num dot message. This one will remove. There is currently one message file. It knows the location already, so it picks up from the msg folder. Okay, so we have done that. Now search for control generate messages. This also will have to uncomment. Dependency standard and yeah, we'll have to uncomment this. Okay, alright, so we save it now. So now if we go back to our terminal, yeah, I think all set here. So if I do ROS message show beginner tutorials num, it automatically comes the num. It identifies the message on its own. So you see, if you type it, it shows the content of the message type num. It contains the first name, second name, age and score. Okay. If you just type ROS message show num, it still shows, it tells you the location where it is and gives you the content. Okay, now we'll see how the service file is created. Again, we'll create another folder called srv cd and cdsrv okay, we'll do this. And I think service files are a little more complicated, so here we will use roscp to copy the files from another package. So what we do, roscp, it is another useful command for copying files from other locations within the roscp, then rospy tutorials, add to ins.srv, it is already there, so we'll copy it to srv. srv slash add to ins.srv with the same name. We'll do that. So if we go to srv cd srv, and if we just see cat add to ins, so they're not complicated, but just we copied from other location. So you see it has two parts. The things above the line are the inputs that you need for making a request, and below one is the output, that is a response that will be given out by the server. Okay, so here also we'll have to make some changes to the package.html. so we have already done it. You'll have to uncomment the message generation and message runtime lines, and you have already also changed the cmake list file, and where we have added message generation in the find package. Now only another one thing we'll have to do, add service files. So we go to our editor and search for add service files. Yeah, so now we uncomment it. Okay, Control S. And we change the files. For example, it is not there, and add to ends. We don't have to give the folder name specifically, because it will search for srv folder, so we just provide the files to be included here. Add to ins.srv. Alright, so now if we go back to our terminal, cd, if we say ROS srv show beginners tutorials, so automatically the add to ins comes and it shows you the content of this one. And if I just type show add to ins.srv, you see it shows 3 instances of it, one with beginner tutorial, other with ROS Pi tutorial, another with ROS EUS. So the same service is available with 3 different packages, so that's why you can see all the instances of it. Okay, so I think we have already done it. Generate message dependencies, standard message, we have done it. So if we have done it already, let's check this one. This is in the CMake list, generate messages. So we'll see here, control F here, sorry, generate messages. Yes, we have already done that and it is uncommented, so we have saved it. So now let's go to our this. So we'll go to cd catkin make. If we do, hopefully it should not give any error. So it creates various codes. For example, it creates list code for the message, it creates Python code for the message and also for the servers, okay, and JavaScript code for message and the services, C++ code. So this is what it does. The once you provide the template, it creates respective codes for all these languages. Okay, so it is done. All right, so just to end this session, you can see the various options that are available with ROS MSG by typing ROS MSG-H. So you have all this show, info, list, MD5, all those things. Okay, so and you want to see ROS MSG show and you want to get help for that, it tells you that you have this option with show. You can see raw file, bag file, and etc. All right, so just to review, we have already seen ROS pack command. We have that means to get information about a package. ROS pack find, ROS pack list, all those things are there. ROS cd we know, ROS ls we know, it just lists the files within a ROS package. We saw now new command called ROS cp that allows you to copy files within from one ROS package to another ROS package. Okay, then we saw ROS msg just to get information about the messages, and ROS srv to get information about service files, and yeah, so all right, so we'll stop here for the time being, because the next session is little going to be longer, because we are talking about how do we write our own publisher and subscriber nodes. So we'll stop here. I hope you found this session useful. Thank you very much for going through this video.